Hello everyone, welcome to Learning Club. If you are watching this channel for the very first time, don't forget to subscribe our channel and hit the bell icon. So without any further delay, let us start our today's video. In our today's video, we are going to discuss variance and standard deviation, properties of variance and standard deviation for frequency distribution data, and their examples. This is the first video of the series of measure of dispersion. In our previous video, we have discussed the types of measures of dispersion and we have discussed what is measure of dispersion in actual. Now, from now and in our next video, we will discuss variance, quartile deviation, mean deviation, range, etc. etc. So, what is variance and standard deviation? The variance and its related measure, the standard deviation, are arguably the most important statistic. They are used to measure the variability, but it can be seen through its uses that both these measures play a vital role in almost all statistical inferences procedures. In simple words, what a variance and standard deviation is actual in vertically means that it is the value which discusses the measure of variability of the data. The population variance is represented by sigma square and the sample variance is denoted by S square. In other words, variance is a measure of how spread out a data set is. It is calculated as the average square deviation of each number from the mean of the data set. Also, standard deviation is the square root of variance. Means variance is the basic of standard deviation. When you calculate variance, then take the square root of that variance. The answer will be considered as standard deviation. Formulas of variance is for ungrouped data, means in which a data in which we don't have frequency, is S square is equal to sum x minus x bar square, means sum of deviation of square divided by number of values. For frequency distribution data, S square is equal to sum f x minus x square, again sum of squared of deviation divided by total frequency. And if you want to calculate standard deviation from this variance, just take the square root of this formula. The answer will be termed as standard deviation. Now we will discuss the properties of variance and standard deviation. Number one property of variance and standard deviation, as we are considering variance as the base of standard deviation, so the product of variance and the number of values on which the variance is based is equal to the sum of squared of deviation from mean. The first property. The second property is, if we have n values of a variable x1, x2 up to xn, then variance S square should be greater than equal to 0. In other terms, it should be positive. Number 3. If each of the n observation, means x1, x2 up to xn, is equal to a constant a, then variance is equal to 0. Remember in mind, just keep in mind that these are the properties are similar to standard deviations. Number 4, if we have n values of observation of a variable x and a and b are constant, and if y is equal to a plus bx, then sy is equal to b mod sx. It is the relationship between two variables, which usually termed as when you want to calculate slope, just divide the variance, the standard deviation of one variable to the standard deviation of another variable. Property number 5. For symmetrical and moderately skewed distribution, the following empirical relation holds. Its mean deviation should be 4 over 5 s and its standard deviation 2 over 3 s. For a simple and symmetrically moderately skewed distribution. For normal distribution, the intervals mean plus sum plus minus s, means plus minus 2s, mean plus minus 3s includes 68.27%, 95.45%, and 99.73% of the values respectively. Example number 1. Given the following set of numbers 204, 203, 207, 206 and 209, calculate variance and standard deviation. For the sake of, according to the definition, we have to first calculate mean of these values. So sum x is equal to 1029, mean is equal to summation xi divided by n, 1029 divided by 5 is equal to 205.8. Now the next thing which we have to do is minus this x bar, the value of x bar from the original values of x. So when we subtract 204 minus 205.8, we will get minus 1.8. 203 minus 205.8, we will get minus 2.8, and 207 minus 205.8, we will get 1.2, and so on, 0.2 and 3.2. Then sum of square of deviation we have to calculate, because according to the definition, variance is sum of square of deviation divided by number of values. So when we take the square of minus 1.8, we will get 3.24, minus 1.2 squared is equal to 7.84, and so on, 1.44, 0.00, 10.24. The sum of square of deviation is 22.80. The formula of variance is equal to sum x minus x bar square divided by n. Putting the value, we get 22.80 divided by 5, and the answer is 4.56. Remember, this is the answer of variance. When we want to calculate standard deviation, it will be equal to, standard deviation is equal to under root 4.56, which is equal to 2.13. Consider the example. This will be probably of frequency distribution data or group data, or whatever you want to say. Given the following frequency distribution, you can see that in our first row we have x wages values, and in our second row we have frequency, and the required answer is find the variance and the standard deviation. For the sake of solution, according to the definition, we first have to calculate summation fx divided by summation f, mean of the distribution. So we first have to calculate the column fx. So we multiply column x with f. 22 multiply 1 is equal to 22. 27 multiply 6 is equal to 162. 32 multiply 10 is equal to 320, and so on, 74, 42, and the sum of this column is 620. Mean is equal to sum fx divided by sum f. We are putting the value, and we will get 31. The next effort of ours is subtract this 31 mean value from each value of x. So when we will subtract 22 minus 31, we will get minus 9, 27 minus 31 minus 4, 32 minus 31, 1, 6, 11. Now we have to take the square of this column. Minus 9 square termed out, 81 minus 4 square, answer 16, 1 square is equal to 1, 6 square is equal to 36, and 11 square is equal to 121. Now we have to multiply this column, column number 5, with frequency column. So we will get 81 multiply 1 is equal to 81, 16 multiply 6 is equal to 96, 1 multiply 10 is equal to 10, 36 multiply 2 is equal to 72, and 1 multiply 121 is equal to 121. The sum of this column is 380. According to the definition of variance, the formula of variance is s square is equal to summation f x minus x bar whole square divided by summation f. Putting the values 380 divided by 20, the answer is 19. Now again, when you want to calculate standard deviation from this variance, just took the under root of this variance. So under root 19, the standard deviation is equal to 4.36. Now another question emerged in our mind. In our mostly frequency distribution data, we do not have given directly a values of x. The examples are in terms of class boundaries or groups. So first we have to calculate x, which is equal to the midpoint of upper class boundary plus lower class boundary divided by 2. And the remaining procedure is same. Thank you for watching the video.